the last thing we're going to do in this workshop is to give you an idea of how the TypeScript compiler sees your code. And we're going to do this through taking a tour of a really quick and dirty documentation generator that takes advantage of all the information the compiler gathers as it parses and type checks your TypeScript source code. So let's look at, in the notes section, at number 9, Compiler API. So first, this is proof that I keep using isDefined over and over again. I just cannot seem to get by without it. We're going to import, this is called a wildcard import. We're just sort of getting everything from TypeScript, from the TypeScript module. We could do like import create program from TypeScript. Oops. And then we'd be able to use create program directly. But all this does is it allows us to do ts.createProgram. There it is. And this is just because we need a whole bunch of different stuff. But it's a little nuance that is kind of TypeScript specific. You don't see wildcard imports in JavaScript. So the first thing we're going to do, we're going to create a TypeScript program, and we're passing in two things. This first object here, options, it is equivalent conceptually to your tsconfig compiler options. So we've got target, we could have module, and say ts module kind common.js, whatever we want to put in there. It's all, these correspond to some of the command line flags we were looking at when we first played with the TypeScript compiler, and it's also what's in tsconfig. The second thing we must pass is root names. And so what I've done is using Node's path module, I've joined together an appropriate path that leads to the example we compiled in that first thing we did as we were poking around with how to turn TypeScript into JavaScript. So it's pointing to the TS file. The next thing we're going to do is grab this program, and by the time we reach this line of code, it will have been compiled and type checked and it's ready to go. We're going to get all of the source files and filter out those that are only declaration files. And this is a good opportunity for me to kind of show you what all is brought in automatically to your program. So I'll comment that out temporarily. Console log non-declaration files. Let's just call that files now, since we're going to skip the filtering. And I'm just, for the purposes of logging, I'm just going to transform them. They're objects, and I just want the path name. So I'm going to run this code. Oh, I didn't save. My bad. And we have a whole lot of different stuff. Someone who's used TypeScript before, can you tell me what these files are all about?
They're type definitions for various different libraries.
For Node, right? Anything that starts with @types, those are from the definitely typed, master repo of public type definitions. You could get to those by just clicking into stuff that I'm importing from the various Node modules. @types, Node, path, right? So these are all of the different Node modules. So let's keep looking around here. There's some more types Node stuff, lots and lots of it. And just scanning for when things look a bit different. Here's Mocha and Chai, so I'm using those for testing. Okay, finally we have the original source file in hello.ts. Note that everything else has been a DTS file. These are just declaration files that are being imported. And then underneath, because this is printed from the first things that are parsed all the way to the last things. Like, I lost my place. So here's the program. This is what I would consider my source code. Underneath that, we've got ESNext, right? These are actually declaration files that come with TypeScript itself. So that's where I can click on something like, what's a good example? Map, array.map, part of the programming language, right? Well, we find ourselves in a declaration file. So it's not the same mechanism that is used to consume library type information is used to consume the type information for everything we would consider JavaScript. Same goes with the DOM API. And if we looked here, there are actually a couple different versions of these where when we're saying I want to target ES 2017 or 2016 or 2015, you just end up kind of picking a different file here. And a lot of the new ones kind of just stack on top of the old ones because naturally the language is additive as time goes on. So if we're going to build a documentation engine, we probably don't want to document the whole JavaScript programming language. We're going to end up touching on a lot of different things, and it sort of starts to get very big very quickly. As soon as you touch a string, now there are all the string methods, and those refer to arrays, and they're the array methods, and it sort of unravels very quickly and becomes huge. So that is why I'm filtering through for only those things that are not declaration files. Only the TS files, not the DTS files. And thankfully there is a property on there called isDeclarationFile. And if I were to do the same thing now, console log non-declaration files map file name, run it again. There we go. We're down to one source file. Everything else is just extra type information that helps everything compile properly. So the next thing I'm going to do is obtain a reference to the type checker. The type checker, which is part of the compile, it is what takes all of the types and the interfaces you create and the abstract syntax tree, which is the in-memory representation of your code, right? All of the functions and the arguments and everything, and it binds them together and identifies, what is going to actually type check, what is going to work, make sure everything is type equivalent. So it's going to be the source of a lot of the information we're going to use to log out documentation. We're just going to log it to the console to keep things nice and simple. Next, we'll use the type checker to obtain the TypeScript symbol, and a symbol is something that can be imported or exported, right? It's something with a name. Remember, you can have 3 slots on a symbol, value, type, and namespace. That's what we're working with here. And each file is associated with one. So we're going to take all of our files, iterate over them, and for each file, we're going to ask the checker for the symbol at the location of that file. This is just the way you get, we're effectively using the language server a little bit here. We're querying the checker saying, here's a location. It is character 0 in the file, basically. Give me whatever the tooltip would be there. What is the symbol? And then we're filtering out anything that might be undefined. If there was a compile error of some sort or something was really wrong with one of our declaration files, some files might not be associated with the symbol. If they couldn't successfully type check and we had our TypeScript settings really relaxed, some of these might come back I can't give you anything for this. It's just gone. So now we have symbols. And I'm just going to uncomment this block here, and we'll just kind of walk through it step by step. Actually, let's try it out incrementally. So I'm just going to log out each symbol's name. we'll start there. That's a good start. Okay, so this is giving us basically the same thing as before. Let me just make sure my other console log is gone, and it is. So this must be producing this output down here. A file, a symbol associated with a file, its name is going to be the path of that file. So if the file has exports, we will enter this branch here. So let's try to compile that and run it. And we're just like, symbol has a property called exports, and I'm just grabbing that right off of the symbol. Looks like it does have exports. So let's iterate over the exports. Their type happens to be something called an underscore escape map. It's a dictionary. Sorry for all the scrolling. It's just, I want to reveal this bit by bit so we can all follow along. So we're going to iterate over the export, and for each export we're going to log out its name and use this technique with the type checker to obtain its type. This is the exact same thing we use to get each file's symbol, right? Get symbol at location, get type at location. So this will give us a type, and then this is type to string. Self-explanatory. Let's see what this looks like. Here we go. There's the name of the symbol. That's this right here. And then this prints out this string, which looks a lot like what we're seeing in our tooltips. Now, there are a couple steps involved here, but really, once we create our program, get a hold of a file, we can start accessing all of its exports and figure out which ones are functions and start checking on their arguments. At some point today, I got a question about JS doc tags. I think you asked it, Chase, where you wondered, is this part of what TypeScript is parsing, or is it VS Code just adding it to a tooltip? It turns out TypeScript understands these JS doc tags. So here's our value. It's got a method called getJSDocTags, and the rest of this is just getting it into a form where we can easily see it in the console. And there we go. So this is sort of, these correspond to the comments in that code. Let me open up the code just so we can compare what's being logged out. There you go. There's another way, like property we could access to see this string up here. But this looks a lot like what we're logging out on the bottom. So if you were interested in checking your code to make sure that nobody's accessing this old version of the library, of some library, or if you wanted to make sure that nobody's, like you wanted to build a custom linting rule of some sort where you need to understand how all of this code is assembled together. TypeScript is a great tool for that because it understands JavaScript and TypeScript equally well, and you get these pretty reasonable data structures out that you can iterate over and crawl through and use it for something like this. So that's all I have, everybody. I hope it was a useful and fun exploration of TypeScript. I hope you walk away having a better understanding of how type programming works and where to apply type information so that you get a lot of value out of this without running into some of the traps where you over-constrain yourself. Thank you.